So we are looking at the different ways of perceiving the relationship between the semantics and the web. So the first angle that we look at is to see the semantic web as a layer over the text, the textual content, right? Now there the primary question that will arise is the documents, they're already there on the web, right? And you have trillions of documents on the web, right? So it is not really possible for someone to go and put the structured data on these web of documents, every document, right? So the question is how to transform these trillions of web text documents into well structured data. And in that case, the natural language processing techniques, they came into rescue, and there are different programs. For example, I can talk about a project by CMU, which is called the Never Ending Language Learner. And this program, what it does, it reads through the documents on the web every second and come up with a piece of structured knowledge and store that knowledge in a structured database, right? So this particular domain of extracting data out of unstructured data is called information extraction. And there are several programs, and basically there are different data sets who have really where we have the people have used these information extraction techniques to extract structured knowledge out of unstructured data, right? But there are certain issues that we need to keep in mind while we are using this natural language processing techniques. The first issue is that we need to extract data in such a way that it will minimize the additional data that is being added to the original page. So why is that? Because while you are sending a page from the server to the other end, or you are asking the machines to read data from it, if you have huge data assigned to the page, then the data that would be transferred from one end to another end would be a bit at the highest side. So you need to think about that you don't have redundancy in the description. The second issue is that we have to facilitate the reuse of the accumulated data. So I'll not say this is an issue, this is a requirement that after you have created a data out of your unstructured page, that should be made available for reuse by the other programs, right? And the third point that I like to highlight is that if the original page is altered, then there should be a way to update the knowledge that has been associated with this page earlier, right? So these are the things that are points to ponder. There are certain solutions to some of these problems, but you don't have solutions from others. For example, I don't know any such good programs that can resolve the issue of maintenance when the original page is altered. So this is again a challenge that is there. Now you can view semantic web as a giant decentralized database, right? Now if you do so, there would be certain questions arising. So first of all, as we are talking about a giant database and it will be used globally, so that means you have to come up with a structure which everybody understands, or a mechanism to store that is effective for everybody, right? So the question is how to store and retrieve this knowledge and data. What would be the protocol? So what particular technique we can use to store and process these data sets? Now, we are doing all this to perform reasoning. This reasoning would be performed by the programs. Now, to deal with the issue of efficiency, one can think of pre-computing this inferred knowledge. So you have a knowledge base, you can infer some new facts out of this knowledge base, whether you want to pre-compute this and store, or you want to generate the inferences on the fly. To give you a concrete example, We think of a recommendation system. Let's say the Amazon website or Flipkart website. So there you have got the products and the users. The users are buying products, and the products, they have their relationship between themselves, right? Now, from this knowledge graph, one can infer that a particular user who has bought some items would be also interested to buy other items. So basically, we are providing recommendations to the user. Now, this recommendation can be thought of as a pre-computed thing. You can pre-compute the recommendation, or you can generate the recommendation on the fly as the user is browsing through the products, right? So it depends on how you want to build your application, right? In the third view, you can think semantic web as a platform for agents, platform for automated agents or the programs or the scripts. And for that, you need to facilitate a shared communication between the agent. So there can be multiple agents, like one agent is booking a hotel, another agent is booking a flight, another agent is looking at your schedule. So there are multiple agents there coordinating with each other, and for any coordination there has to be a common language in which they can talk in, right? So that's why we need a shared communication, a common framework in which they can operate. And if that happens, then the agents can be interoperable. They can exchange data with each other without any glitch, right? So these are the two requirements if we view semantic web as a platform for automated agents, right? Now, there is a very elegant relationship between the data integration and interoperability. So first of all, whenever you are trying to say that your system is interoperable, you have developed a web application and you are declaring your web application as interoperable. So that means the other programs, they will be able to understand your data, right? But under the hood, you can have a representation of the data on your own, which is your raw data representation, right? But while you are publishing this data for to consume by the others, you cannot really publish the raw data representation. So you have to come up with an abstract data representation, and you have to have a mapping of this raw data representation to the abstract data representation. And this abstract data representation should be independent of individual internal representation of the data by individual websites, right? So this is one important aspect while we talk about data integration. The second important thing is that you have multiple web application 1, web application 2, and web application n, right? And they are publishing data on their own. In order to provide an integrated service, you need to bring this data into a common platform, merge them together. So there would be a requirement of merging this resulting representation. So these are all abstract representation. So these are abstract representation and these are raw representation. And here you are trying to do the merge, right? And finally, if you have a merged representation, you can query the entire database by assuming that this is a very huge database, right? And what benefit you can get? That let's say you have a query that cannot be satisfied by a single source, single data set, but can be satisfied by combining all these data sets together or multiple data sets together. So that is also possible, right? So let us take an example of all the things we have talked about. So the mapping, merging, and query, right? So the example says that there are two bookstores. So bookstore A and bookstore B. In bookstore A, you have got three tables. One table is talking about the metadata of the book. The book has one ID, which is the ISBN, has an author, it has got a title, publisher, and year. So this is a table. And the other table, it relates this author and tries to provide the metadata about the author, the name of the author and the nationality of the author, right? So the title is Gitanjali and the author is Rabindranath Tagore. And the publisher for this book is again put into another table, which is pub 296926, and the publisher name, we are having the metadata about the publisher, which is basically the publisher name and publisher city. I can see that this is a representation that has been adopted by the bookstore A, but this representation may not be understandable by another bookstore, say bookstore B, because they can represent their data in their own way, right? So the second stage of this was to have an abstract, or the first stage is the abstract data representation. You are mapping the internal or the raw data representation to the abstract data representation. And the data representation that we have seen, or the data set that we have seen, can be represented in an abstract way like this. So we have the ID of the book, which can be treated as a node, and it has got a title Gitanjali. It has got a year to be 2010. It has a publisher, but the publisher has got its own metadata, which is the publisher name and the city. And it has got an author. The author again has got a name and the nationality. Now you can see that we are at every step, I'm going back again, at every step we are adding basically a statement. What is the statement? That this has a title Gitanjali. In the next statement, we are saying that this has a year. So we are using the single and simple thing to represent a piece of item, and that single and simple thing is the subject, predicate, and object. And in this case, the subject is the ISBN, the predicate is this title of this age level, and the object is the value that you can get, right? And we are doing this, you can see that we are doing this for everything, irrespective of how they are represented in the database, right? And that's why, as we are using a single and a very simple framework to do so, it is an abstraction over the raw data, right? Now we have another bookstore where you have a book, another book in the store, and the book is called La Offrande Lyrique Gitanjali, which is basically the French translation of Gitanjali. So this book again has its own ISBN, but it is also maintaining, this database also maintaining, is also maintaining the ISBN of the original, and again it has got a year and the translator. Now you can see that the column names, they are in French. So this is to illustrate that the fact that the internal representation, they can be structural, they can be structurally different as well as maybe linguistically different, right? And you can see that this author has been represented as OTR, right? And so this A29 is being again described using another metadata to be having the name to be Andre Guide, and the author of this book has been represented as 898, and A98 is having the name to be Rabindranath Tagore. Now, as we have done earlier, we can represent this data also in a abstract data representation form, as we have done earlier, right? Now let us put this together. So we have got the data about the bookstore B and the data about bookstore A. Now this is a transformed or a mapped version, and this is also a mapped version, the abstract version. Now you can see that this ID and this ID, these are two same. So why don't we merge them? So we can merge them because they are talking about the same thing, right? So if we merge them, we get to see this part, right? This is the merge data, right? Now what we can do with this, we can ask a query which was not possible to answer by the individual data set. And the query here is, what is the title of the original of La Offerende Lyric Gitanjali, right? Now let us see whether we can do better, we can do more, right? So for example, this author and this author, they are kind of same, but they are linguistically different, but they are referring to the same relation. So why don't we merge them? We can merge also the relations, right? So we are asserting the fact that this author and the author, they are the same thing. We are finding an alignment between these two relations. As we can find an alignment between these two relations, we can merge them just by putting the author in the relation. So it will this relation, so this relation will be referring to both author and author. What else we can do? This authors, they belong to person category. So this person is a concept that is understood by your community, right? So we can use the vocabulary from the existing community, which is in our case the FOAF, and which is friend of a friend. So this is a place where you have got concepts and their semantics defined for the domain of representing profile of the users over the internet, right? And this is a very well-known vocabulary. Now, the point that I'm trying to make here, that as this vocabulary is understood and used by the community, you can reuse the vocabulary from this FOA. For example, you are using person concept from this vocabulary. And if you do that, this will be understood by the other programs as well. And what else we are adding, that the author is a type of person, and this author, this author is also a type of person, right? And as we are using standard vocabulary, we can ensure interoperability, which was another requirement if we had looked the semantic web as the platform for the web of agents. And also we can change this A name to FOF name here, and B nome to be FOF name here, because they are well understood by the community. So you have got a different structure now. Now we can ask another complex query, like what is the nationality of the author of the original of La Offerende Lyric Gitanjali, right? So we will be following this path. We will be going from this to this, and then author, and then Rabindranath Tagore, right? So you can see that we started asking complex queries by merging the data, appending something else to the data. We'll not stop here. So as we are expecting that we have a layer over this web of documents, people will be publishing their data in open platform and in a structured way and in a standardized way, we can expect that there will be other data sets out over the internet or web of data. Such a data set is called the DBpedia, which is basically a structured version of information that is there on Wikipedia. Now let us see whether we can merge this piece of information that we have obtained from merging this bookstore 1 and bookstore A and bookstore B, whether we can align this to some concepts in DBpedia. Now in DBpedia, we have entry for Rabindranath Tagore by this node, right? Again, we can add this relation because it was already there in DBpedia, and Rabindranath Tagore is a type of author which we can do, and additionally we can use other relations from DBpedia like notable work, right? And the notable work is another entry in DBpedia which has got an ISBN to be this number, right? Now, there is another important data set which is Wikidata, different from DBpedia. We can also align the resulting graph to Wikidata graph as well. So how you can do? We can say that the Wikidata entry Q7241 is the same entity as Rabindranath Tagore, and this entity has got notable work like this entry and notable work like this entry, and this notable work has got the label to be say Bhanu Singh Thakurer Padaboli, and this entity has got a label like Valmiki Pratibha. So these are the two famous uh, mm, writings by the great poet Rabindranath Tagore. So what we have done here, we started with a small data, and the programs, they will be able to align this data to the existing data set, do some inference, and finally we can answer much more complex query like what are the notable works of the author of the original of La Offerende Lyric Gitanjali. So we can see that we can follow the path like we know we can trace this path, like the answer would be Bhalu Singh Thakurer Padapuli and Valmiki Pratibha, right? So I'm not showing you the path, it will be very easy and intuitive to do, right? So there are few things I have left out while I have discussed this integration, like see this I'm doing this having this kind of structure like something colon type or DBO colon notable work. So these I'll not talk about this at this point of time because there is a quite bit of discussion that is involved, but you can think this to be one relation, right? So we'll be parking this discussion for later class. Now what is happening here? The individual data providers, they have data in multiple format and with multiple schema or multiple representation technique. So the data can be placed as or represented as graph. It can be represented as an Excel file. It can be stored in a relational database. It can be there as XML, or it can be a text, unstructured text document. So the first thing you need to do is a mapping these data to an abstract representation, right? And the abstract representation that we have talked about is basically subject, predicate, and object. So we are mapping the data to the abstract data representation as well as we are publishing the data. So it is not adequate that only you map the data, you have to publish the data, otherwise it will not be discoverable. And if you do so, the applications, they will be able to query the knowledge base or manipulate the knowledge base depending on whether the applications they have access to what kind of access they do have on the abstract data representation or the merged representation. So basically this is the summary of the things what we have done as far as the data integration is concerned. Now you can see that what kind of philosophy that we are trying to project to support semantic web. So the first philosophy is that as an organization you should be open to publish your data whenever you, so that is the first thing. The second thing is if you have an intention to publish the data, you have to publish the data in a standardized form, and this standardized form is really the abstract data representation. And if you are doing so, either you can manually align your dataset by with other dataset just by saying your data item, one data item is same as the other's data item, or relating the data item in many other ways. We'll look into the other ways as well later. And the third thing is that your applications, they should be written in a way so that they can consume the data represented in abstract data representation, right? So the big question now is, we are talking about lots of promises, right? Your document will be, your web will be smarter, your web will be intelligent, there will be a layer of web of data, there will be a layer of sense making for the machines. But the question is it really happening? The answer is, it's already there. We don't just see it. So why I'm saying this? If you go back to say 5 or 6 year down the line, the search for a query, for a given query by Google and any other search engines, you only had the list of results or list of links as results, right? But if you compare those results with the results that you or page you can see in today's search engines, on top of having those, you get something extra. Like you get a card. So for example, if you search for IT Kharagpur, along with the search results, you also can see the knowledge card about IT Kharagpur, like when it was established, who are the notable alumni. So all those things you can see in the knowledge card. So that is something. You can get something better, like you can get answer to specific question. What is the date of birth of say Rabindranath Tagore? So these are the things you can get precise answers, which was not possible 5 or 10 years back. So the point is, the revolution has already happened. As we are using the services daily basis, we just don't notice it, but it's already there, right? So this is, I think, another philosophy of what semantic web they have community they have taken, that it is not like after having the semantic web, your web of document will be gone. It's not like that. So it will be aiding the application by adding a layer of semantics over the layer of data or documents, right? So it is not replacing the web, it is enhancing the capability of the web. So this is a confusion that happens, or that is there in many places, that semantic web is going to replace web. It is not like that. So it is an upgrade of the web. It is not really replacing the web. So let us see a glimpse of this. Who are doing what in the domain of semantic web? Let's come to Google, right? You search for something like this: who invented the semantic web? And what you get? You get as answer a concrete answer: Tim Berners-Lee, right? Which was not possible say 10 years back. So you can do question answering using, and do you know how this knowledge answer is getting produced? Because Google is maintaining a huge knowledge graph which keeps track of, or which keeps knowledge about the entities that are there in the web. For example, Tim Berners-Lee is an entity in the on the web, and that's why Google has information about Tim Berners-Lee in a structured form, in the form of knowledge graph. And if you put a query, a very specific query like who invented semantic web, it will just traverse that the path like Tim Berners-Lee invented semantic web. So it is moving from one node Tim Berners-Lee to the other node semantic web, and the relation is invented, and it is matching with the query, and you get your crisp and clear answer. Coming to the next example, if you put a query like famous Indian musicians, right? Now, earlier you would have got a set of documents which would have will having the words like famous Indian musicians. Well, if the documents they have these kind of words, you will be lucky to get these results. But nowadays, if you put this query, it will retrieve a set of instances for you. So here you can see that as answer we have uh, obtained Pandit Ravi Shankar, Pandit Bismillah Khan, Pandit Zakir Hussain, Pandit Shiv Kumar Sharma, Pandit Hariprasad Chaurasia, and A.R. Rahman, likes of A.R. Rahman. So they are all instances of famous Indian musicians. So what Google can do for you nowadays is the instance retrieval using knowledge graph. So basically, in the knowledge graph, what is mentioned that Pandit Ravi Shankar is an instance of Indian musician. Ustad Zakir Hussain is an instance of Indian musician. Ustad Bismillah Khan is an instance of Indian musician. Right? So you can see that the web is getting smarter and smarter day by day. You look for something like chicken butter masala, and what you get the recipes, and not only less recipes, you get something like the ratings that have been received for the recipe provided by Swasti, the time to cook, the ingredient, the procedure. So you get a very structured answer to your query. And again, thanks to the concept of web of data and knowledge graph, right? So you have rich snippets. So these are called rich snippets. So now Google, they are providing rich snippets which are context dependent. Like for recipe, you will be having a separate kind of rich snippet. But if you search for a publication, there you will get a different kind of rich snippet, like how many times this publication was published, like that. Right. Now the other important aspect which has been improved at the Google's end after adopting this web of data approach is the search engine optimization. Now, the search engine optimization is a technique where you adopt some strategies to make your website get into the top rank of Google, right? And there are many companies who are providing services to take your web page or website to the top in the Google list, right? Search list. Now earlier it was a kind of black magic. So there were some set of experts who have the know-how how to trick Google's algorithm and put your website at the top. So there are very basic strategies like you put the same word again by again, or you refer to, or you put some important links in your website. So there are many strategies to do this search engine optimization. Now after this, and the thing was not very transparent, and Google was really grappling with this problem. Now after this structured data approach has come, Google, what they have done, they have provided the option to let the content developer to describe their content in a standard vocabulary and standard format and put that micro data embedded into the document, right? So this is one approach. And if you do so, Google will index your document better in a very meaningful way. So it is now not really relying on simple keywords. It is also looking at whether the content providers, they are providing structured data. And if they provide structured data, Google trusts those content providers more than the content providers who are not providing structured data. This is one benefit. The other benefit is that I'll again talk about the application where you have a login based system, and if you log into the system, you'll get access to the books, right? Now, these books, though they are hidden under your login uh, wall, they can be made discoverable by putting the semantic metadata about these resources which are behind your login wall. And this description, if they are made public, then Google can index those, right? So you can see that the things are getting more transparent. Google knows that why they are indexing your document and why they are putting your document in the top of the rank, right? So this search engine optimization, it has got become more transparent. Coming to Facebook, back say I think again 5 or 6 years back, the posts that you make in Facebook, they were restricted, or you can share a post that is made on the Facebook from the Facebook itself. So you cannot go beyond Facebook. Or let's say you are reading an interesting article and you want to share that with your friend. It was not really easy back after say before say 6 or 7 years. Now after I'll say 10 years, now Facebook, they came up with something called Open Graph Protocol in 2010. So what it does, it provides a very simple mechanism to someone who is reading third party content over the internet, and attach that content to your social network, right? And that is done through something called Open Graph Protocol. Now, this is an example that I have taken from the National Digital Library of India, where you can get into a content page and you can share the content page from the from this page itself without logging into the Facebook, without being into the Facebook. Again, you need to have a Facebook account, of course, right? Now, if you share, you can see that this URL will be attached to your social network, and it is part of your network now. Now you can do many inference with the network that you have got, right? So this is becoming to be a huge knowledge graph. Again, Facebook is also maintaining a knowledge graph of friends, who is doing who is sharing what content has been borrowed from the third party applications, and they are providing meaningful services like recommending friends, something like those. Microsoft, they are pretty much into it, in being they are using it very extensively. They have a very important product which is Microsoft Academic, which is a kind of network of citations of the publications by researchers from multiple domains. And you can see that a publication has got a domain, has got several authors, it has been presented in a conference or a journal, and again they are forming a knowledge graph, and you can do very meaningful inferences or develop meaningful applications out of this knowledge graph. Microsoft has also released something called ConceptNet. It's a concept network of different concepts, again in a graph form, right? So knowledge graphs, they are becoming part of every application. And needless to say, Amazon, they are using it extensively. Amazon Alexa, how does it answer to the queries put by the users? Siri, Apple Siri. So they are also using knowledge graphs to provide answers to the user's query. Amazon's product graph, I was talking about recommendation in Amazon. So they are using product graphs to explore whether they can provide better recommendation to the users by looking at the connection between the users and the products, the connection between the users to users, the connection between the products to products, right? And needless to say, the things are becoming better and better. LinkedIn, they are keeping in the record of different professionals of different domains, different institutes, and there you can see that it is also a huge network of experts of different domains, the members of different domains, and they have good recommendation algorithms, and they are in some way related to processing the knowledge graphs. Now, I was talking about another requirement to make it happen is a common language. Now, one can say, how will this common language emerge? Of course, some of them will be centrally controlled, like this DC term. They have been, they are being controlled by Dublin Core Metadata Initiative Group. It is not a single person organization. It is a community of multiple persons spanning multiple domains and multiple countries. They are coming up with a vocabulary or the language by which you can describe any digital resource. I will like to talk about schema.org. It is a product of thought process of Microsoft and Google and Yahoo to represent any web document in a structured form. Simple knowledge organization system, friend of a friend, creative commons. So there are many such vocabularies. So as of now, there are around 723 vocabularies in linked open vocabulary. So these are all open. Anyone can use this vocabulary to describe any resource in his or her own organization and publish the data. And as we are publishing, as you are representing the data using a common language, people or the algorithms or the programs, they will be finding it easier to process your data. This is what I was talking about. This schema.org, it has got a single place in my slide because this is a very important vocabulary, and it was developed with an intention that it should be able to let people describe any digital document, right? So I was talking about the recipes, the rich snippets, the search engine optimization where we can provide structured data along with the content. So if you use the schema.org vocabularies to describe those recipes, those metadata about the content, Google will index you better, right? And the other search engines, they are working in a similar fashion. Now you can say that, well, I know that there are vocabulary described for different domains. Is there data out there? And believe me, there are plenty of data available out there. DBpedia started to be the biggest resource of structured data with the internet. You can think of it to be the structured version of the entire Wikipedia, right? Now, the project of Wikidata came into picture, which is basically a collaborative way to create structured knowledge. So as Wikipedia is a collaborative way to create document, so those are human readable document, this Wikidata is a semantic web version of Wikipedia where you can create structured document following some standard vocabulary. Different government organizations, they are coming up with open and standard data like the data.gov. They are having plenty of data sets in open domain and in semantic web domain. And bio2rtf is a huge data set of related to biology and bioinformatics related domain, right? So the point is, the vocabulary is there, the technique is there, the data is there, the applications, they are using it. So the thing is really happening and we don't see it really, we don't feel it. Now you can say that, well, data is there, what is the big deal? Are they connected? Because that was the basic tenet of web of data, right? And you have this project linked open data. They have the mission to connect all these structured data. Those have been published but they have not been aligned. You can see that DB in this graph, in this network, DBpedia is at the central edge, central part, and they are being connected with the other data sets. And you can see that there are connection, they are bidirectional, as well as they are having relative strength of or weightage of strength, right? So this is basically saying that how many times geoname is being referred by DBpedia and DBpedia is being referred by geoname, right? So these are alignments, they are making it possible to connect the data sets with each other, right? And this was the picture back in 2008. This is the picture in 2011. Now you can see that almost they are not perceivable. So that's why the designers, they have segregated the data or the network in the form of colors, right? So for example, these yellow color nodes, they are referring to geography domain. For example, this pink color nodes, they are referring to life sciences domain, right? So this is back in 2011. So let us look at 2017. So this is the state of art. You can see that these nodes are getting smaller and smaller. Now in 2007 we had around 149.4 billion triple. You can think of the scale of it, and put together there were around 1163 data sets, right? And this is today's scenario. I just have taken this snapshot maybe 2 days back. So this is, you cannot really see that there is a very elegant way to cluster the disciplines. They have mixed with each other. It's very hard to separate them out. And we are having around 1,260 data sets. The data sets, they are getting increased day by day. So to give you a snap of this, this is the cluster of the government related data set. This is the cluster of life sciences. This is the cluster of linguistics related data sets. This is the cluster of publication and citation related data sets. So what is semantic web then? The answer is, it is a collection of standard technologies to realize a web of data. If we think in the terms of technology, you have many technologies like W3C, RDFs, and you see that internet, all the protocols, all the languages, they are controlled or weighted by World Wide Web Consortium. So they standardize all the protocols and other things related to the web. And they have also standardized the technologies and the concepts related to semantic web. So for example, this RTF, which is basically the resource description framework, is weighted by or standardized by W3C. OWL again is the language for the sense making layer. It has been standardized by W3C. SparkQL is a query language for the data, web of data. So there are many other techniques or vocabularies. Those are standardized by W3C. And semantic web is basically the collection of all these technologies to realize the web of data. If we talk about in a technological perspective, but in philosophical perspective, it is a kind of movement to elevate the web of documents to the form of web of data, a intelligent or a smarter web. So in the next lecture, we will try to see the broad vision of semantic web and what would be a possible architecture to realize this broad vision. So until then, thank you very much. We'll see you in the next class.